Hey there! Today we have quite an interesting problem to dive into. Let's talk about the curious case of GHCi's behavior when it comes to evaluating functions in Haskell. We have a scenario where two functions, f and g, are defined and called in a GHCi session. Despite being defined in a similar manner, the evaluation of x equals f5 and y equals g5 yields different results. We're going to unravel why this happens and explore the intricacies of GHCi's seek function in the evaluation process. Now, let's take a closer look at the solution to our problem. When code is loaded into GHCi, breakpoints are automatically added to the functions. These breakpoints are enacted by default, but are essential for later debugging. The presence of these breakpoints alters the behavior of code evaluation. Specifically, looking at the core representation of function f, we can see how breakpoints are integrated into the code structure, affecting the evaluation flow and potentially leading to unexpected outcomes. Continuing with our exploration of the solution, let's shift our focus to function g. Unlike function f, g does not have breakpoints sprinkled throughout its definition. This distinction is crucial as it impacts the evaluation process. By examining the core representation of function g, we observe a cleaner structure without the interference of breakpoints, resulting in a smoother evaluation path without the added complexities introduced by the breakpoints. Moving forward, we now delve into the implementation details of function f. The definition of f includes the utilization of breakpoints within the recursive calls, influencing how the function is evaluated step by step. This incorporation of breakpoints in the recursive logic plays a significant role in shaping the evaluation process, ultimately impacting the final outcome of the function in terms of WHNF evaluation. As we proceed further, let's dissect how the function x equals f5 evolves during evaluation. The step-by-step breakdown reveals the impact of breakpoints on the evaluation chain, leading to a specific structure where parts of the list remain unevaluated until reaching WHNF. This delayed evaluation due to breakpoints results in the observed behavior where the tail of the list in X remains linked to unevaluated funcs. Bringing it all together, we reach a pivotal moment where we demonstrate how turning off breakpoints for loaded code using no breakpoints eliminates the difference in evaluation outcomes between X and Y. By disabling breakpoints, we can observe X reaching WHNF in a manner similar to Y, showcasing a consistent evaluation approach across both functions. And that's a wrap on our exploration of GHCi's behavior in evaluating Haskell functions. Remember, if you enjoyed this video, don't forget to hit the like button and subscribe for more intriguing tech content. Leave a comment below with your thoughts, and until next time, happy coding!